Welcome to Cut the Crop, keeping you in the know about everything you grow. Researchers, growers and other interesting folk delivering insights and information on topics ranging from agronomy to profitability. Brought to you by the Foundation for Arable Research.
Hello and welcome to Cut the Crop. I'm Anna Heslop and today my guest is Pieter Hendriks, who recently joined Lincoln University as a lecturer in arable crop production. Pieter has a farming background from France and a research expertise in weed management. He completed his PhD on the role of root architecture in wheat crops, and that work was done in Australia. Welcome.
Thank you for having me.
So today I'm going to be talking to Pieter about some of the work being carried out at the CSIRO, which was where he was most recently working.
Exact, in Canberra.
To breed wheat cultivars with greater early vigour that are able to outcompete weeds.
Yes.
So, first major question, how much of a problem are weeds for cereal crops?
That's a good question. So without any care, weeds can take out approximately 35% of a crop yield. So it is a big issue and it's the major biotic stressor for crop production.
And has that always been the case?
So historically crops are good competitors because they grew really tall, but through the aim of improving harvest index and the whole work that's been done during the Green Revolution, this competitive ability was drawn back at the same time they improved yield.
What happened actually?
So what happened is that plants were bred to be shorter, to have a lower biomass, but a higher yield. And the issue with that is that it also left the canopy open for light to come in and therefore allowing weeds to grow much faster.
Okay, so some of those traditional pre-Green Revolution varieties were much taller.
Yes, they look a lot like a rye crop, a modern rye crop. They could stand chest tall. I've got pictures from my grandfather from 1928 where he's harvesting a wheat crop and it stood almost as tall as he was, and was not a tall man, but still that was 150 centimeters.
And so the harvest index, obviously the ratio of seed to stem there was not so good.
Oh yeah, no, that was it was about 20% in those days, and I think the absolute aim for wheat harvest index now is, I think we're trying to get to that 50%. And we're not there yet, but it gives you an indication of how much biomass was reduced and how much yield was improved.
So in all of these modern breeding programs, what we've done is we've got higher yields, but less competitive because they've also become a bit more reliant on pesticides? Exactly.
So in the current system that came out of the Green Revolution, we were heavily relying both on tillage and on the chemicals that came with the Green Revolution. So with these chemicals, we're actually capable of maintaining our weed impact below the 10% of our yield. Unfortunately, these solutions have their own problems.
And those problems are?
For example, erosion when it comes to tillage, but you also have issues with herbicide resistance using the same product over and over again. Weeds adapt to it and create a resistance to it. But there's also, I think, an increasing push from the public to actually reduce the amount of chemicals that we use as farmers. And that's something that's only going to increase over time.
Okay, and so that leads us into what we call that integrated weed management.
Yes.
Which is, well, you define it for me.
So integrated weed management is a set of tools that doesn't exclude chemicals. It is actually taking chemical as one of the tools. So competitive wheat, what I've been working on, is one of the other tools, but you can look at longer rotations, density of sowing, the geometry of your sowing. All of these are solutions that are available to improve the competitiveness of a crop and therefore use less chemicals, but also hopefully making sure that the chemicals that are available at the moment have a longer life expectancy. Tell us about that work at the CSIRO. What are they doing and what are they trying to achieve? So when I arrived in Australia, I had the pleasure to join Dr. Greg Rabetsky's group. And Greg has been working for 20 years on a recurrent selection. So the way that works is we take the most vigorous available cultivars around the world We randomly crossed them, and the 10 best % performers based on width of leaves get selected, and they get crossed again. And you do that for 6-7 cycles onwards, and you end up with a crop that is much more vigorous. And vigor above ground is one of the traits that we look for when it comes to competitiveness.
So is that more leaves, or is it more height, or is it both?
So the pure recurrent selection, you end up with a monster plant. It is a very tall plant. It has leaves that are very wide. And if you would compare it to a standard crop, we're looking at leaves that are twice as wide. So these are quite amazing plants. They're not agronomical valid. So what Greg then did was crossing those lines into commercial cultivars and trying to maintain some of those advantages that came out of this recurrent selection.
But maintaining the actual grain yield as well.
Exactly, because what happens with these very tall plants, you fall back in the historical problem of low harvest index. So what Greg has demonstrated is that you can improve this vigor while maintaining your harvest index. So it's mainly looking at early vigor.
So is that above ground vigor, or does it include the root system? Because that was the subject of your PhD, I think.
Exactly. So Greg and his team have been working on above ground vigor for a long time, but nobody had a good look at what was happening below ground, and that's where I got to play with the roots. And so, the vigor is actually looking both above and below ground. Growth of a plant is some kind of an equilibrium between above and below ground. And what I demonstrated is that the vigorous above ground plants also have a much vigorous below ground root system. And that vigor actually is visible earlier than above ground.
Because the roots are growing before it comes up through.
Exactly. And competitive-wise, competition below ground starts much earlier and is probably more intense than the competition above ground, because roots are already competing for space, water, and nutrients while they're not shading each other yet.
So that's the benefits are potentially twofold. You've got a more vigorous plant above ground shading out weeds, and you've got a more vigorous and larger root system below ground that's out competing the weeds down there as well.
Yeah, that's correct. So above ground competition is about light. So a system that closes its canopy faster will outcompete weeds than a system that has open canopies. Below ground, what counts is root length, the number of and length of root hairs, because they pick up the water and nutrients. And what I've found is that the vigorous material grew roots deeper into the profile, so they have access to more water and nutrients. They grow faster, so they occupy this volume faster, leaving less space available for the weeds. And in our case, that was ryegrass, which is the major weed issue in Australia.
So what did it show with the ryegrass?
So our competitive crops could reduce ryegrass growth 2 to 3 times more than a non-competitive commercial cultivar.
And what was the impact on yield?
So very limited from what we've seen, fortunately, because that's usually the first question that we get when we explain this to farmers is, okay, but the plants put a lot of energy in this early growth. Is that an issue when yield comes, especially in drought-prone environments like Australia? And what we demonstrated is that in 3 of the 4 environments, there was no statistical difference. And in the 4th one, which was actually a wetter one, there was a short reduction. But it was significant statistically. It was not a huge reduction.
So these are research crops, or are they commercial crops?
So I've got another colleague, Catherine Involksen, who was working with Greg Robetsky. She has now joined a breeding company in Australia, and they are working on making these traits available to commercial crops. But what we did is we took 2 or 3 commercial crops available in Australia, Wildcatcher and Yitpi, for those who might know them, and we crossed vigor in there. And so we compared Yitpi to the lines that were progeny of Yitpi and vigor.
Okay. And so that showed quite good results.
Exactly, yeah. So in a completely chemical-free environment after sowing, so we didn't spray for weeds after sowing in Wagga, we saw that the weed biomass at flowering was 3 times lower in our competitive crops than it was in the commercial cultivars they were progeny from.
How long have you been in New Zealand now?
I've arrived in New Zealand in October with my family.
Okay, so not too long. Do you have a view as to whether these sorts of crops would also be beneficial in New Zealand cereal systems? Because obviously the issues are a wee bit different.
Yeah. You have a completely different system that has not at all the same problems. However, I think these type of solutions could be adapted everywhere. When it comes to competition above ground, as I said, the idea is closing that canopy faster. And even in our really good growing conditions that we have here, I think there's still an opportunity to improve the competitiveness of wheat.
So a possibility for the future. Now, there was one other thing that you picked up along the way, and that is allelopathy, which is a plant exudate or something that comes out of the plant roots into the soil that can suppress other plants.
Yes. So to say complicated, this is the exudation of secondary metabolites by the roots into the soil system. More clearly, it's actually the root who's releasing chemical molecules that slow down or stop the growth of a competitor. And so ryegrass, whether it's resistant to herbicides or not resistant, does react to those molecules.
From wheat?
Yeah, from wheat.
And are there any other cereal crops that have this allelopathic effect?
Yes, a really good example of that is sorghum with sorghum. That's a well-described phenomena. But rye corn, a more common crop here in the Southern Island probably, rye corn has a high allelopathic capability. And if you have a look underneath your rye crop, you'll see that it's generally much cleaner than underneath a wheat. And
that's just that natural trait of expressing molecules that will take out.
Yeah, it is. It's a mixture. It's once again, this crop is, as it's physically more competitive, but it's also chemically releasing more of those molecules.
So is there any work, do you intend to do some work or encourage some work on this in New Zealand?
Yeah, I would be really interested to get involved, of course. It is possible to breed for this, and the Scandinavians have demonstrated that by actually creating two varieties, commercial varieties that are sold as being more allelopathic. And that was a commercial breeding effort. So again, these are crops that didn't lose any yield potential. It's an extra. So it is possible to actually achieve these goals.
To summarise, what role a competitive wheat might play in an integrated weed management package for New Zealand wheat growers?
Okay, that's a really good question. Like everybody would know who's been farming, is there's no absolute silver bullet. But the advantage of a competitive crop is that it will reduce your weed seed bank, also your weed impact during the growth season, but more importantly, the weed seed bank for the next generations of crops that are going to be growing in the field. And this is done at a very efficient, cost-efficient way because farmer doesn't have to invest in new material. They don't have to learn new techniques. It is just using the right genetics. And one of the advantages of using this as amongst other tools is that you will reduce the cost of your chemical input, but it will also extend the life expectancy of your chemicals. So I'm not preaching here for throwing out all the chemicals from one day to the other because there is no silver bullet. What I do preach is these molecules that are available now are very valuable. The rate at which new molecules are discovered and brought onto the market is slowing down. So we need to make sure that we can actually keep those molecules functioning. And my point of view, adding extra tools like my competitive crops is just one way of extending also the life expectancy of the molecules that are available at the moment.
Thanks very much, Peter. Let's just hope that with some breeding, wheat will continue to beat weeds.
Thank you.
Thanks very much, everybody, for listening, and have a great day on the farm.
Thanks for tuning in to Cut the Crop, presented to you by FAR. If you'd like to know more about any of the topics discussed or have any suggestions for future topics, go to www.cutthecrop.co.nz.